Diamonds are special not just because they are beautiful, and they are, but because they have lots of unique properties. Crystals of pure carbon, diamonds have exceptional brilliance, dispersion and scintillation that make them coveted gems. They are harder than anything else on Earth, ranking 10 on the Mohs scale. They have the highest thermal conductivity at room temperature, 5x greater than copper. They have the highest molar density on Earth too. You'd have to travel to a neutron star to find atoms packed more closely together. These properties come from the structure of diamond. The tetrahedral bonds between its carbon atoms are exceptionally strong. This bonds only form in extreme conditions. That's why diamond only forms naturally deep in the earth under tremendous heat and pressure. And that's what makes diamonds so difficult to create in the lab too. So how do scientists create lab-grown diamond crystals here on the surface of the earth? There are two processes: high pressure high temperature, or HPHT, and carbon vapor deposition, or CVD. Both processes form actual diamond crystals that have all the special properties of diamonds. In fact, no one can tell by looking at diamonds whether they were grown in a lab by HPHT or CVD or whether they were mined from the earth. How to make HPHT diamonds? The HPHT process for creating diamonds was first developed in 1955 by General Electric scientists. Initially it produced only tiny diamond crystals for industrial purposes. Over the decades, HPHT-grown diamonds got bigger and the quality got better, although they were generally yellow-orange in color until relatively recently. In the HPHT process, scientists grow diamond crystals under extreme heat and pressure, the conditions you'd find deep in the earth. A diamond seed is placed in a huge press filled with a liquid metal catalyst and some carbon and subjected to about 800,000 pounds per inch (2) of pressure and 2,500 degrees Fahrenheit. Gradually, over days or weeks, a diamond crystal grows on the seed. The longer the crystal is left to grow, the larger it will be. But if there is a fluctuation in temperature or pressure, the final crystal may be flawed, so growing large gems can be risky and expensive. HPHT lab-created diamond crystals are cuboctahedral in shape, with both cubic and octahedral faces. As the crystals grow, the process leaves behind traces of the process on an atomic level that gemologists can use to identify them as HPHT diamonds even after they are cut and polished. For example, HPHT-grown diamonds may contain tiny metallic inclusions from the catalyst, trace elements that show the cubic structure, and traces or boron that make them electrically conductive. Today HPHT lab-created diamonds are made in colorless, near colorless and fancy colors. The process can produce fine flawless gems, but you'll also find a wide range of lower qualities too. Although the HPHT process was used to create the largest lab-grown diamond so far, a 150-carat rough crystal, it is most often used to create small lab-created diamond accent gems. The lab-grown diamonds in your pave band or halo are almost always produced by the HPHT process. How to make CVD diamonds? The CVD process was first proposed in the 1980s, but for a long time no one thought it would ever work to create carat-sized jewelry-quality diamonds. That's because CVD is a completely new way to grow diamonds that doesn't use the extreme pressure or temperature that mimics diamond formation zones in the earth. Instead, CVD uses plasma. Plasma is often called the fourth state of matter, after solid, liquid and gas. Stars are made of plasma, hot ionized gases. When gases are heated in a vacuum chamber to form a plasma, their electrons are freed and their atoms can easily react. In the CVD process, hydrogen and methane gases are heated to 800 degrees, freeing the carbon atoms from the methane. The carbon then deposits on a cooler diamond seed, growing more diamond, layer by layer, atom by atom. CVD lab-created diamonds form cubic crystals with only one growth direction. The challenge is growing diamonds that are thick enough to cut and polish into gems. CVD-grown crystals can be removed from the growth chamber to have the surface repolished so they can continue to grow thicker. The largest CVD diamond ever grown is about 16 carats. However, CVD-grown gems from 1 to 5 carats are now widely available. Most center stone lab-created diamonds are produced by the CVD process because the growers have more control over size and quality. CVD diamonds are always type IA diamonds, which are very pure with no nitrogen. That means they often have very good clarity. They can sometimes have a brown tint that can be improved if their growth is finished in an HPHT chamber. HPHT versus CVD diamonds, which is better? Just like natural diamonds, lab-grown diamonds are graded by independent institutions like the Gemological Institute of America and the International Gemological Institute. If you are buying GA-graded lab-grown diamonds or ED-graded lab-grown diamonds, the most important thing to consider is the 4 Cs of diamond quality. Whether a lab diamond is HPHT grown or CVD grown, its color and clarity can range widely, so it's most important to choose quality first rather than process. Because lab-grown diamonds are much more affordable than mined diamonds, our customers usually decide to trade up in quality. We recommend you choose G or better color for your lab-grown diamond and versus clarity. You can also trade up in size as well as quality because lab-grown diamonds cost so much less. A 2-carat FVVS diamond, which would cost more than $30,000 if natural, is less than $5,000 if it's created in the laboratory. In the popular GH versus qualities, 2-carat lab-grown diamonds are around $3,500. That's the total price, not the per carat price. If your diamond is a ½ carat or smaller, it will probably be created by the HPHT process. If it's from 1 to 3 carats, probably CVD. But no matter how it was made, making sure you are buying a certified lab-grown diamond will ensure you have the quality you deserve. Meet with a gemologist. Rockher's team of gemologists is available via live chat, phone, and email to help you choose the diamond that's right for you. 1-800-779-1726. Let's chat. Recent post. Why you should buy super ideal cut diamonds. Lab-grown diamond engagement rings under $5,000. The difference between natural and lab-grown diamonds. D flawless for 90% less. Why consumers are choosing lab-grown. Lab-grown diamond buying guide. 6 diamond buying myths you probably believe, but shouldn't. Versus diamond versus SI diamond. Which should you choose? Should you buy your engagement ring at Shane Company or Robbins Brothers?